Any idea how you prove this? So how do you prove that this as a function of t is convex? So what kind of manipulation you will do? What are the things that you can do? Okay, so what I'm going to do, let's try these things. Okay, so I'll take I plus x outside, right? Identity plus x is always invertible. Why? Can somebody prove that identity plus x is invertible? See, identity plus x, I can write it as identity plus, so what kind of matrix is x? X is positive, semi-definite, symmetric. So the moment I say positive, semi-definite, symmetric, what comes to your mind? Apart from symmetric and positive, semi-definite, obviously. But what else? Huh? Of course, that's what you mean by positive, semi-definite, right? Huh? Eigenvalue decomposition, right? So we can always do eigenvalue decomposition, right? So now I can write it as UU transpose for identity. So I'll take U to the left. This will be identity plus lambda, U to the right. Okay. Now what is the inverse of this matrix? Maybe I'll write this as an aside. What is the inverse of this matrix? So you have U identity plus lambda times U transpose. So I have to multiply it by U to cancel U transpose, right? U transpose U is identity. Identity plus lambda is a diagonal matrix with diagonal entries being equal to some value greater than 1, right? So it is invertible. So I can do inverse, right? U transpose. This is your inverse. So this matrix is invertible. So I plus x is invertible. And I know the inverse also, right? So what I'm going to do is I'm going to take the inverse out, or I plus x out, okay? So I'm going to take identity plus x out. What do I get? I get identity here, right? In the place of identity plus x, because I have pulled it out. Then what do we have here? We have t times y, right? If I pull a matrix out, A plus B, if I pull A out, what would we get? Identity plus A inverse B, right? Yeah. So I should get t times identity plus x inverse y. Do you agree with this, everyone? See, I have log det of identity plus x times something. What is determinant of AB? What is determinant of A times B? Determinant of product of matrices is product of determinants, right? Determinant of AB is determinant of A times determinant of B. So I can use that, but I have a log outside. So log of product is sum of logs, right? So I'll have this. Plus, what is the next term? Next term is this. Identity plus t times identity plus x inverse y. Okay. What is the next step? If identity plus x is a positive semi-definite matrix, obviously, right? X is positive semi-definite, y is positive semi-definite. Sum of positive definite matrices will always be positive definite. In fact, it is positive definite symmetric, right? So what can you say about inverse? You already saw, right? Identity plus x is basically this, right? Inverse is basically this. This is definitely symmetric, right? If you take the whole transpose, U transpose becomes U. I plus lambda whole inverse transpose is I plus lambda whole inverse only. And then U becomes U transpose. So it's symmetric, right? Okay. So now I plus x whole inverse is symmetric. Y is symmetric and positive semi-definite, right? So what do you think is the next step? So what should I do? Any idea? What should I do? Any what do you think is the next step? What should I do?